In this video, I will demonstrate how you can create a pairwise matrix plot in the KIWI ExploreLive module. A pairwise matrix plot is actually a square-shaped matrix of plots intended to show the co-distribution of the variables included in your datasets. I will demonstrate the use of basic settings, such as the selection of the data source, and the selection of the variables that will enter the matrix of plots. I will also demonstrate the use of advanced settings controlling the design of the matrix of plots. I have an active ExploreLive session in which I have already imported a dataset. This is the same pharmacokinetics dataset we've used in other tutorials. I have created a subset of this dataset in a modified version. In this modified version, I kept only the first record per subject. We will use this dataset to create a matrix plot. So I will click on the plot menu and then select the pairwise matrix plot option. The interface opens and show a plot setting panel at the top, and the region where the plot is created is actually at the bottom in this submodule. In the plot settings, the first field is the field that allows you to select the source data for your matrix plot. This field will list all the imported data sets, any modified data sets that you could have created in the data module, and if you have pooled or merged two data sets together, the pooled data would be viewable here. I will select the one per ID data set. And then the next thing I have to do is just provide the list of variables that I want to include in my matrix. So I will just select age, weight, WTKG, creatine clearance. You can include both continuous and categorical variable in whichever order you want. So contrary to the other plot module or submodule of KIWI Explore, in the pairwise matrix plot, you actually have to click on the Create Update Plot button to generate the plot. The reason is that the engine that generates the plot is a little bit slow. So updating the plot at every modification of the UI would create a lot of activity and a lot of unnecessary activity. So you have to click on this plot to generate the matrix. So the matrix lists the variable in the order you have provided them. So it's a square matrix. The diagonal of the matrix displays the distribution of the variable. So age is continuous, so you have a density plot. Same for weight, creatinine clearance. SexF, C, and study C are categorical variable. So you can see a bar chart in this case is showing the relative distribution of those two categories for SexF and the three categories for study. The lower triangle will contain scatter plots when the two variables associated with this panel are continuous. So in this case, we have age as the x-axis against weight. So So weight is the y-axis in this case. So this is the scatter plots for age versus, weight versus age. This would be the creatinine clearance versus age. Creatinine clearance is the third. This panel here is the creatinine clearance versus weight. When a categorical variable, SEXF, the SEXF is the Y variable, is shown against a continuous variable. This is going to give you a histogram of sort. So the panel is actually broken into two panels, one for the female. So you can see that in this little strip here. So female data would be shown in this part. So this is a distribution of age for the female subject and the distribution of age for the male subject. The same way for the last variable, the last row, which is study. We have three studies, MAD, POC, SAD. So a little bit harder to read this one because there is no strip associated with that. You just know that the MAD is the very first variable or first value. So that would be the distribution of age in the MAD, distribution of age in the POC, and a distribution of age in the SAD. So that's for the lower triangle. In the upper triangle, a correlation is shown, which would represent the Pearson correlation factor from a linear regression run on the data shown in the symmetric panel across the diagonal. So this would be the correlation for the weight versus age linear regression. Same for the creatinine clearance versus age, creatinine clearance versus weight. A box plot is shown in the upper triangle panel when we're crossing an age, a continuous variable on the y-axis, which would be your age, against the SEXF, which would be the variable for the x-axis in this case. So you get different distribution box plot in the upper section. A few things that you can control here are the number of beans that are used for creating your distribution histograms. Not going to show that, but this number will be applied on all the histograms. You can use a stratification variable. It may not be the most intelligent one, and I'm probably going to have to categorize that in this field. You can transform continuous variable like the dose variable into a categorical variable. Oopsie. And now I'm going to create the plot or update the plot. Just have to wait a little bit. And now the data is stratified by dose. So all the information that was displayed is now stratified by the different values of dose, which could take 8 different values. So this matrix is a little bit busy, and the information is not necessarily super hard to, super easy to interpret. But sometimes it's useful to stratify by a variable that can take 1 or 2 values. So for example, if I switch, I remove my SEXF variable and just add a dose variable here and use SEXF instead of the dose variable for stratification. You should see only two groups in the bottom panel, so that might be a little bit easier to interpret. So all the information, including the correlation factors, are provided for the different groups. In the case of the correlation, you get also an overall correlation. There are some other settings that you can change. You can change the darkness of the background of the plot in the matrix. The lower you get, the lighter the background, the higher value you select, the darker the background. So just to illustrate, I will go for 60. And then you can see the data with a darker background. You can also select a different theme. The two first themes are the KIWI and KIWI Solids. They are very similar and should not give you too much difference in terms of the final product. The ggplot2 theme is the default color scheme provided by the ggplot2 package, which is the graphical engine that we use to generate these plots. Some people are more familiar with this color theme and could select this if they prefer that. The pairwise plot matrix offers some functionalities that are covered in separate videos, such as the data subset. This is strictly the same functionality that is described in a tutorial called data subset or subsetting data. You can also download the matrix plot, and this is also a feature described in another video called download plots. So with that, this concludes the presentation of the functionality offered by the pairwise matrix plot in ExploreLive, in the ExploreLive module. If you have any questions, you can always refer back to the KIWI user manual or send us questions at kiwisupport@cognigencorp.com. Thank you very much.